Hello guys, welcome to my channel Quantum Astrophysics. So let's start today's discussion. Quantum physics describes the science of the very small things, tinier than billionth of a meter. On the scale of atoms, subatomic particles and the wavelength of light, it also shows how many properties are quantized on these tiny scales, subdivided in discrete units rather than being continuously varying quantities. In our everyday world, it's hard to imagine the properties found in this microscopic world. For example, there are particles like electron that have no physical dimensions and others with no mass. Strangest of all, however, is the notion that particles can act like waves and waves can act like particles. This simple yet profounding fact lies at the heart of quantum physics and everything that subsequently flows from it. Quantum theory has its roots in a fierce and long-running debate over the nature of light. The question as to whether light is made from particles or waves dominated science in the late 17th century. In 1678, Dutch scientist Christian Huygens popularized the hypothesis that light propagated in the form of a wave. Of course, waves need a medium through which to propagate. It was clear that light waves were not using air as a medium. Space was known to be airless, and yet we can still see the light of the sun, stars, and planets. To get around this, Huygens hypothesized a medium that he called the luminiferous ether. He neglected to explain exactly what this ether was, beyond it being weightless, invisible, and apparently everywhere. Surprisingly, many scientists, key among them Isaac Newton, were unconvinced by Huygens' wave theory. He proposed a model of a light as discrete particles, so-called corpuscles. It was based not only on objection to the wave theory of Huygens but also upon observation. Newton pointed to the way in which light is reflected from a mirror. Waves do not travel in the straight lines needed to create a reflection, but particles do. Furthermore, Newton explained refraction as the effect of a medium attracting particles of light and speeding them up. Finally, step outside on the sunny day and you will see that there are sharp edges to your shadow, whereas if sunlight were made of waves, your shadow would surely be fuzzy. Newton's model became the leading theory of light, but it wasn't well received by everybody, and his rival Robert Hooke was one influential voice who still favored the wave theory. Then, in 1801, long after Newton's death, the double-slit experiment seemed to dispute corpuscles once and for all. In the next video, I will explain double-slit experiment. Thank you for watching my video.